Okay, welcome back. So this time we'll start with a long running session. So we have Rajith Attapattu talking to about hacking your open telemetry pipelines. So Rajith, please take it away.
Thank you for the warm welcome. I hope all of you are doing well. And after the lunch, luckily I'm not doing just after lunch. So hopefully most of you are awake. So my name is Rajith. I'm the founder and CTO for Randoli. And I'm going to talk to you about improving the quality of your telemetry. Uh, Let me take a second to introduce Randoli because some of you must have not heard. And hopefully it'll also give you some background on why I'm talking about this project and how I started down this path. So Randoli is an observability platform, and how it is different from the traditional observability vendors, and you will see why I'm talking about this topic now. The traditional observability vendors will ingest all your telemetry into their platform and provide observability. And what Randoli went down was to process, analyze, and store the telemetry locally and only ingest the signals. So what that meant was we had to think about how to increase the quality of the signals and how to extract the relevant pieces and not ingest all the, otherwise we'll be ingesting noise. So when we got down that path, and this, it's a very simplified architecture diagram, we started looking at how to do that, and that's where OpenTelemetry fit into the picture. So with OpenTelemetry, it allowed us to help, extract signals by processing raw telemetry. So now you might be wondering why you should care. Maybe none of you are using Randoli, but why would you care? And how is this applicable to me, right? Maybe it could be you're already using a different observability vendor, or you could be doing do your own observability with open source. Either way, there is a cost for observability, whether you do open source or otherwise. And generally, the cost of observability comes from is directly correlated to the amount of data you ingest. The more high quality data you have, the better for you. So even if you're paying a price, it's at least valuable to you. Otherwise, you end up ingesting a whole bunch of low quality telemetry and you pay the price. So for example, recently, I know for government customer that we're working with, someone turned on debug logs for their MuleSoft instance, and then there was a massive overage in cost. So the quality of the telemetry, again, useless. It's not going to help you in production at all, but you paid the price. Even if you have open source tooling, the cost of storage, the cost of managing, all of that is going to add up. So the quality of the telemetry is important, and that's what I want to talk to you about today. Right. It's no brainer. This is how much these days it costs to do observability, and it's getting higher and higher. So just a way to emphasize. And one other thing I wanted to talk to you about is the value of owning your own telemetry. And towards the end, I'll talk about some interesting things that we ended up doing because we had access to the telemetry itself. So OpenTelemetry, today we had a nice talk earlier today as well. One of the biggest value propositions for me of OpenTelemetry is the choice it gives, not just the choice it gives to the end users, but the ability to control your telemetry and own your own telemetry. Because once you have the data, you can do a lot of interesting things. Let's start with a very quick intro. How many of you are aware of OpenTelemetry or familiar with OpenTelemetry? Of course. Others I would have asked it. Yeah, Julian is an expert. Hopefully you guys tuned into his talk. So a lot of people have heard about OpenTelemetry. I'll do a very quick intro for the folks who haven't, and then we'll get to the interesting parts. Probably the most popular CNCF project right now. If you go to KubeCon, they have their own big booth, right? Pavilion. Highly recommend to test it. And I also think this is why you should pay attention to OpenTelemetry, because there's a very vibrant ecosystem. So anytime there's an open standard, Generally, the risk is not enough vendor support or not enough community around it. In this case, there's a lot of vendors behind it, a lot of community around it, so it has legs, so something to kind of pay attention to. Right. So very quickly, some basics in OpenTelemetry. It's a couple parts to it. So one is how you instrument the data. There are multiple ways to do that. There is, the auto instrumentation in the Kubernetes, and we are in KCD, so I mentioned that. There's the hotel SDKs, there's APIs. So it provides you with a vendor-neutral way to extract telemetry from your applications, which also means that you can switch vendors. There's a lot of flexibility that it gives you. There's also a protocol called OTLP, OpenTelemetry Line Protocol. If anybody worked in a standards organization, generally this kind of protocol helps to prevent misinterpretations or leaving things up to interpretation. So there's a protocol behind it as well. So now you extract the data. The next part is the OpenTelemetry collector. This is where the magic happens, this yellow box, and my talk is primarily based on the yellow part, right? So you extract the data, you funnel it through your OpenTelemetry pipelines, and then you have a choice of where you want to send it. You can send it to multiple backends. You can send it to, there's any number of backends. It could be a vendor platform. It could be any open source tool. It could be both. So it gives you this choice of which backend you can send it to as well. So you have choice in the front of it, where how you extract in a vendor neutral way. Then you have the pipeline in the middle, where you can take control, right? And then you send it. So that way, even if you are using an observability vendor, by improving the quality of the telemetry, by using the OpenTelemetry pipelines, you can get better value for your money. Okay, good. Now, let's look at this part very quickly, and then we'll jump into the different sections. Right. So I talked about the hotel collector, the yellow box. This is what it looks like in the YAML form. So there's a couple of key sections here. So one is, the receivers. That's how you receive the telemetry. When you annotate, when you use the annotations, or whether you use SDKs, you'll eventually end up sending the data to an hotel pipeline. And the receivers are responsible for taking it. And then you have the processes. These processes are I would say, where we get to exert most of the control. So I'll talk a lot more about that. And then once you process them, then you can export it to the backend, right? To various backends. Now, the pipeline part is you take all of those pieces and put them together. It's like a little bit like code. You have these different modules and you put things together. So that's the pipeline part. This together is what you call an hotel pipeline. And you can have multiple of those. I'll talk about those different patterns and stuff like that as well. All right, so now we've covered the basics, and good. We can jump into the topic at hand. All right, so first thing, we'll talk about some basic use case. How do you filter out low quality? So one of the things that you can do with these processes is add filtering. So number one, what if you just do something very simple and drop debug log? Sometimes people forget to set that configuration, and that gets deployed into prod. But the people who are administering the OpenTelemetry collector can, in fact, do things like this, so that it doesn't matter what happens with the applications. You get a little bit of control. That way, you're not funneling debug logs or things like that. It's very simple, but pretty effective, right? And so that you can avoid some of those surprise bills, or just fill up if you're using open source, fill up your storage, right? So it's a simple one. At the end, I have, I will eventually put this into some GitHub or something. So if you want this, just send me an email or hit me up on LinkedIn, and I can give you a way to copy some of these things. All right. So that's the. Let me explain a little bit for this one. So in the processor part, you see the filtering. One is by the severity number, and sometimes that doesn't always work. So you can do like a text-based filtering part. And what you're saying is, in my logs pipeline, I am going to add those filters. So I receive through OTLP. I do the filtering. That's I don't know if you guys can see my mouse. Yeah. Okay, good. And then you export it to your logging backend, and and it could be anything. So here just put debug, but it could be to OpenSearch, wherever you want, Elasticsearch, FluentBit, wherever you want to send. Very simple use case. Let's look at another one. And if these spans doesn't work well, there's Giuliano here. He's the he deals with span. Yes, yell at him. Yes, yell at him. Yeah. All right. Let me talk to you about something called red metrics. And if you're using spans have something called span metrics to get this. But how many of you are familiar with red metrics? Okay, good. All right. So red metric stands for rate, errors, and duration. And it's a great way for you to understand what your customers are experiencing or users experience, right? The CPU and memory doesn't directly correlate to, maybe your CPU is fine, your memory is fine, but your customer is having all kinds of errors or experiencing high latency. That doesn't necessarily translate into resource pressure, right? So generally, CPU and memory, you have to measure that, but by looking at red metrics, you're able to get a better gauge of what your customers are experiencing. And these three things that I've talked about, like how often requests happen, how often they fail, and how long they take latency, right? These are actually extracted by using span metrics. So if you're using distributed tracing, there is this easy thing that you can do by enabling here, right over here. You see that span metrics? Like I said, if there's a bug or anything, there's a man, yell at him. I don't know if he's directly working on it, but he's a trace expert, so you can always yell at him. So you can enable the span metrics, and then you can enable certain dimensions. So these are things that, Julian, is it attributes or processors? I always forget the term. Like attributes, you see, that's why he's there. So you can always pick certain attributes from that and add as dimensions. So now what happens is, when these metrics, you can push it to Victoria metrics or Prometheus, these get added as labels. Now these are coming from the spans. If you look at your spans or attributes. So what happens is, as your spans are collected and calculated, your OpenTelemetry pipeline will start to calculate some metrics. And this will immediately help you build your red metrics, because using those span metrics, you can figure out latency, errors, of course, throughput, right? And by just simply making this configuration in your hotel pipeline, and then picking some of the dimensions, you can get something like this very easily, right? Now, there are some caveats around this. For example, if you're doing some sort of sampling, especially traces can be pretty verbose and very heavy. So if you're getting like 1 million spans an hour or 1 million spans, in a minute or something like that, it's pretty high. So there's generally people apply sampling and stuff like that. So if you're relying on span metrics, then you have to think about that, because otherwise you have to adjust to the sampling rate. Otherwise you'll get the wrong data, right? So that's the red metrics is sampling, right? Okay, now let's build up on this. Enriching telemetry, right? How do you create high value signals from them? So I'll take an actual use case that we ran into. We had this service, this microservice that used both Kafka and NATS. They're both messaging. So if you look at the span metrics, it tells me they're both categorized under the messaging system. How do I figure out which of these parts really, how much does Kafka take versus NATS take? Because they're all lumped into the same bucket now, right? So how do I figure that out? So what we ended up doing was something like this. We can take the what we get with the span metrics, and we enrich it to add more granular signals. So now with the same set, you have added some dimensions. Now it's giving you more visibility, right? So you can increase the value of the telemetry that you're getting. So here what we ended up doing was, we added in the span types, there's something called messaging system, and that tells either Kafka or NATS. So that way I am able to figure out which one is which, right? And now I get if I do Prometheus queries using PromQL and stuff like, I get the breakdown. Instead of this high level view, I can get a breakdown. So by adding these kind of attributes and enriching the data, you can improve the quality of the metrics. Any questions on this one? No? Good. Right. Cardinality, like you've got, you guys must have heard about high cardinality. But yeah, it's generally super expensive. There's a good reason to, there are very good reasons to use it. But in general, if you look at high cardinality, it is because of, I wouldn't say bad telemetry, but poor telemetry, right? So I'll give you an example here. Look at this one, right? So I am collecting metrics for, let's say, my shipping service, right? Now I want to add my HTTP route into as a label. The problem with this is if you have something like order number in the path, now for every different order, it's going to add it. That's going to bloat up your, if you're using a vendor, that's a massive bill. If you're using Prometheus locally, whatever, it's going to increase the storage. It's going to make your Prometheus slow, right? Because for everything, it produces a unique time series, right? So it's important to understand how labels affect cardinality and how it affects performance and storage and stuff like that. So if you're deep into this, it's something good to understand. And this is useless from a business perspective. More or less, you'll only get this order number. It won't repeat, right? Because every order it's a different one, right? So from a business perspective, absolutely useless, and you're paying the price for it. But you could do something like this by normalizing. You substitute that part. Now you would know how many requests you're getting for this endpoint versus another endpoint, right? Because that might be important, because if you have this kind of metrics, you will know the error rate for this, you will know the latency for this, and it's useful from a business perspective. So now, I had the wrong, well, I'm just showing the thing, but what I want to show you is, and I'll come back to that, now you could build monitors and alerts and stuff like that based on that better signal that you correlated out of it, right? So with coming back to here, you could use, this is, by the way, you can write custom processes. I would probably recommend Golang, and then you can embed it. But just for illustrative purposes, I put it here. So what we're doing here is substituting that. It's going to be crazy to put it over here if you have a lot of stuff. But generally, what's happening here is we're taking out the high cardinality of it by swapping it and normalizing it. And this allows you to now collect better metrics that has some business value for you. Right. So now let's build on top of it. Another one. I've seen this in any number of times when you're collecting stuff, like something like user ID, right? Useless from a business perspective. It might be useful from like a security and other things, but when you're calculating certain metrics, there's no reason for that to go into Prometheus, right? Maybe in your logging system, so you want to figure it out, but you'll see these things flowing into Prometheus or flowing into vendor platforms, just ballooning cost and adding value to no one except for that company's shareholders. So look at how you can delete. It's either you're enriching some data points to make increase the quality of it, or you're deleting something, or you're aggregating to make sure the quality of the metrics that you're outputting, right? So you can easily do something like this to delete some of these things, and if it's like only a couple things, you can do it in line, or you can always write a custom processor. And it's pretty easy to build the OpenTelemetry collector and have your own OpenTelemetry collector. If a smaller company like us can do it, anyone can. So that's how you can get rid of that. And let's look at the next section. All right, so pipelines. So remember I talked to you about that pipeline at the beginning? Now, with OpenTelemetry, what's something that's really nice, and I came from like a software engineering background, and I was always a big fan of reusable components and putting them together in interesting patterns. That's one of the the most beautiful things about OpenTelemetry to me is you can combine these pipelines to do really interesting things. So one of this is an actual thing that we do in one of our dev environments. We extract, like we instrument one layer with one primary OpenTelemetry pipeline, and then we funnel them to another pipeline that actually keeps more data because we're doing some experimentation. So more raw data and different types of data, and then we put them into some different storages, and then the rest actually is a little bit more processed, heavily refined, and it sends to one of our monitoring agents because we want to monitor the platform. So the difference here is that you are categorizing the, I've kind of mentioned here, you're categorizing the data. So you're tiering your data, and you can think about retention differently now. Because not all, so here's the other thing, like generally your business data, if you're operating at scale, you'll think about different data tiers, and they all have different value, right? And different scaling requirements. Some data, very temporal, so you can just keep it for like, I don't know, a couple hours to a day. Some data you want to keep it for a week, some for months for compliance and other reasons. So different tiering. And it's the same thing. I think you can think of your telemetry in the same way. Your telemetry data has different values and different requirements. So some data for a short period of time you can keep maybe low value telemetry because you're doing some number crunching and analytics, right? The more refined data can be kept longer if you're doing things like SLO monitoring and stuff like that, and you don't need to keep all the raw data. You can keep some very highly processed data. So by using these open telemetry pipelines and combining them in different ways, now you can enforce data tiering and also treat them like in different ways. So here's another. It's a reverse example. In this one, multiple open telemetry pipelines combining into like a single one could act as a gateway. So there are different ways, interesting ways you can combine these open telemetry pipelines and treat data differently. Gives you a ton of flexibility and control over your open telemetry data before it hits your backends, and that could include your vendors. So you take ownership of your own telemetry data and control. And yeah, so I talked about this, and once you think about this angle, it opens up a lot of interesting use cases. So for example, this is something we initially built. We had a small SRE team. We ended up building something like this, and and now we've sort of rolled it into a product. But what we ended up doing was, because we had access to different classes of data, categories of data, we built agentic AI things on top of it, because we don't have enough human SREs to do some of these things. But having access to the data is what made this possible. Because if you don't have access to the data, and if it's all shipped out of your environment, you can do this. And then second, garbage in, garbage out. If you have low quality, low value telemetry, then doesn't matter, you can use the best AI in the world, you're going to get junk out of it, right? So think about taking ownership of even if you use a vendor platform, you can still store it locally. And second, improving the quality of the telemetry, because that gives you better value, higher signals, and then you can do a lot of interesting things. Because I think the future of observability is going to be very different from what we see today. There's going to be a lot of agent tech. I mean, AI is a buzzword, but there are lots of practical use cases that you can turn on to. But that all starts with having access to data. So think about that, and you can do a lot of interesting things. And then finally, I just stayed on time. If you have any questions, please reach out. If you need those samples, either hit me up on LinkedIn or send me an email, and I'm happy to share them with you. And I think we have a couple minutes for questions, right?
Yes, so we'll go with the questions now, and if anyone has any, let me know. I'll bring the mic over.
Either did a really shitty job or a pretty good job because nobody has questions.
Yeah, so it's not a question, but maybe just a small comment. So when you're hiding these debug messages, you're actually not resolving the problem, you're hiding the problem. And you're just cutting the possibility to the SRE guys to debug those things on the production when they need this, because you will hide this on this level. You will just block them from debugging possibility on one cluster, for example.
So debug logs, especially in production, I mean, so first of all, if someone is marking a log as debug, it shouldn't be useful. So there could be a problem in how you categorize your logs. And so generally, if there are logs that you really need, then I'd argue they had to be at a higher severity and better supported, right? And the second thing is, you're dropping it before you put it into storage, but you can still look at it. And that's with OpenTelemetry, let's say you really need it, you can also funnel them elsewhere for some temporary, like you can keep it a day or two, whatever. And then, but in the longer term storage, you don't store your debug log. So it really depends on how you're going to do it. But I would argue, like logging, in my opinion, is one of the last resorts when it comes to production. Like a lot of people underestimate the power of logs, but also people, like that's the one that I've seen people screw up the most as well and cost a lot of, because if you don't do your logging properly, you spend a lot of time debugging and sifting through, yeah. But yes, I see what your point is, but I would argue, like you'd have to categorize your logs properly, and there are still ways to do that. If you're worried about that, just in case you don't trust the developers, then you can have a tiering system, yes. Any other questions from anyone? Good. Okay. Juliana, no difficult questions? No? I'm just giving you that. Oh, nice. Oh, very nice. Oh, very good, very good. Now I can shit on him too. No, it's amazing. I think I mentioned in the previous talk too. I think OpenTelemetry has created this ecosystem that lowers the barrier for entry and enable innovation, right? Like different models have come up because of the work that you guys are doing in OpenTelemetry, 100%. So hats off to all of you. All right, good. Shall we?
So this mic isn't working right now, so I'll just have to shout. So we'll have a